We're very happy. Just say that I want to announce that the second talk this morning in Asia is by Professor Nori Namiki from the National Astronomical Observatory of Japan, and he's as you will hear, he's in charge of the planning of this Artemis program of Japan participation in the Artemis program. Without more ado, I would ask Professor Namiki-san, please start your talk. Thank you very much.
First of all, thank you very much for inviting me for this seminar. And I would like to introduce our recent activity for the Japanese participation to Artemis program. Of course, Artemis is international space exploration led by US, but Japan has decided to attend it. And as a scientist, we try to understand the significance or values of Artemis for Japanese space community. And we have been discussing. So I briefly introduce summarize our work. And please understand this is ongoing work, and the situation regarding Japanese space program is changing quite rapidly. So this talk maybe will be very different in a few months. Okay. So for Japanese scientists, first of all, I would like to show the Japanese announcement of the Japanese government, which has been done October in 2019. It's named the Policy of Japan on the Participation in International Space Exploration under the proposal of the United States. And international space exploration is now called Artemis. And in this announcement, they declared the new activity for Japanese science and technology community. And they discuss that the participation is important from the 4 points of view. First, foreign policy and security, national security. And second is second point is that Japan should show their international competitiveness and presence. And third, they hope to expand the industries, including those who are not related to space so far. And fourth, Japan should proceed deep space exploration from Moon to Mars. So the importance of this announcement for scientists is that the science is not the top priority for Japanese Artemis. It is actually the fourth. And nonetheless, we are looking at not only the activity on the Moon, but also to Mars. And here, the announcement also focuses on 4 items. First, the first and the second is related to some technological development. And it is a kind of a continuation from International Space Station activity in international space exploration. So Japan will provide supplies, materials using Japanese rockets to Gateway. And the third and fourth are somehow related to space, science and technologies. In the third item, the government says that we share the lunar data on lunar surface, data obtained by Kaguya. We share those data for the selection of landing sites, etc. And in the fourth item, they say that Japan will develop rovers, specifically the pressurized rover for astronauts to move around on the surface of the moon. Okay, so these are the declarations, and in this slide I try to explain the organization structure in Japan regarding this Artemis program. I think that many of you know that Japan has a space agency named JAXA. And under JAXA, there is an institution of space science and astronautics, which is called ISAS. And ISAS is a top institution that is leading the space science communities. And however, independent from JAXA, there's a committee named the Committee on National Space Policy, which belongs to the Cabinet Office. So somehow JAXA and this committee is independent, and because this committee is belong to Cabinet Office, it is supposed to be superior to JAXA. They have they make a basic plan of space policy. They revise the basic plan of space policy every 5 years, and the JAXA need to follow this basic plan. And for specifically, especially for Artemis, JAXA organized a new group named the Center for International Space Exploration. This center is mostly working for management of Artemis mission. So they work together with industries, but they are not taking care of the science. So they inquires the scientific issues to the ISAS. And the ISAS organized the new committee named Committee on International Space Exploration. And they also have several task force groups. And I belong to one of this task force group. And we submitted the task force report. So today I will introduce this report, mostly these reports and activity of task forces. As a background, I would like to show the roadmap of JAXA ISAS for the solar system explorations. The bottom line is that Japan focuses on sample return missions from small bodies, which started from Hayabusa and Hayabusa 2. And the next major mission is MMX. Other missions, international collaborations with NASA and ESA are also supposed to be part of this roadmap. We are very interested in solar system formation and how the Earth and the ocean, the habitable environment formed on the Earth. Independent, other than ISAS roadmap, the community has its own goals for the planetary science in next 10 years. And Japanese scientists are interested in kind of astrobiology. But there are not many astrobiologists in Japan. but most of us are working for the planetary formation, planetary system formation, and also the geophysics, geology, etc. So we've decided to focus on habitable formation of a habitable environment in the solar system. We are not aiming to discover extraterrestrial life itself. And so in this point of view, as I already said, the supply of water from outer solar system to the inner solar system is the most important issues in next 10 years. So these roadmaps have been established before the announcement of Japanese government. So the study of the moon or Mars are not very focused or a major part of our roadmaps. But we think we need to work for, let's say, we need to consider these roadmaps even under the even in Artemis program, because the number of people and are very limited in Japan. And also the funding is limited. So we try to incorporate the Artemis mission in our original view of those roadmaps. So we first let's say as I already said that we decided to focus on the prebiotic chemical evolution in the solar system, and we mostly proposing a mission to small bodies. On the other hand, the Artemis, or International Space Exploration, is more or less focuses on the Moon and Mars system. And we think these two programs are connected in the view of transport of water and organic compounds. So even in the Artemis program, we think this topic, the transport of water, is the main subject for Japanese planetary scientists. Okay. And probably in the later part, we will move to the next topic, scientific topic, which is the atmospheric and the formation of atmospheric and the surface environment within our solar system. Okay, so in a task force member, by task force members, we discussed the 3 months, we conducted 3 months studies. The first one is organized in 2019, October to December. And the task force group submitted the report about a year ago. So I will most introduce today this report mostly. And next October and December, we try to devise this report and continued, improved our discussions. The new report is under edition. We are editing a new report and to be submitted in February to ISAS. So I briefly introduce this, the this report later in this talk. And the two main subjects we discussed last year is collaboration of science and technology and collaboration of academia and industries. So first of all, I will introduce task force report in 2019. This report is somewhat similar to the Artemis 3 Science Definition Team report, which is published, I think, last year, but not as inclusive as this US report, of course. I think those reports are similar because we have been, the lunar science has been discussed many international scientists for many years. So it is not surprising. This slide is introducing the most recent mission, proposed mission for, most recent Japanese, the next lunar mission of Japan. It is a lunar polar exploration named LUPEX. This is ongoing mission. It is approved. And this is a robotic mission by JAXA and Indian agency, ISRO. So these two space agencies are sending lunar rover and lander to explore the South Pole region with the moon in 2024. And the purpose is to discover of water in the South Pole area. JAXA is likely to provide a launch vehicle and the rover. And ISRO would be responsible for the lander. And this, as I said, this is a mission for resource exploration, not for science. This is disappointing for us. At the beginning, 2 years ago, we were told that the LUPEX mission is half resource exploration and half science. But we realized that the mission was finally decided to dedicate it for resource exploration, not for science. What we'll do is we use the data taken by LUPEX for lunar science. Before this LUPEX is, when the LUPEX is proposed, the Committee of National Space Policy, it's a policy-making organization, asked the science community two questions. First question is there really water on the moon? And if there is, how much and where? So we try to answer this question by reviewing the previous works regarding the water on the moon. And as you see, that the estimated abundance is widely different from 0.08% to 30%. But so we concluded that there must be a water in polar region. We are sure, but its abundance is uncertain. So we try to make a guess and where is water. And first, the neutron spectrometer are the most reliable data sets, we think. And hydrogen is widely distributed in polar areas, specifically in latitude higher than 85 degrees. So this area should be the target of Japanese lunar LUPEX. And also we are surprised to see that the water abundance is not necessarily high in permanently shadowed regions. So we are relaxed. That observation allows us to relax the requirement for the Japanese rovers. So that it doesn't have to go into the deep area of permanent shadow. Okay, next we try to understand how deep the aquifer would be. And there's no observational constraints for this question. Only we could do is that review the simulation of water pumping. When the H2O is sublimited at the surface, those will be evaporated, and some of them are going to the subsurface. And one simulation shows that the water is most abundant at the depth of 70 centimeters, and the other says 50 centimeters. Anyway, we think that the water reservoir is somewhere between shallower than 1 meter. So that gives us an idea how deep we should drill by LUPEX mission. Okay. The difficult question is in what form those water exist. Either H2O molecules or hydroxide, and we don't know. So this is very important for the utilization of water, but we are not sure. So so the second question is that if we are not sure, how do we know about the water on the moon? And the answer is quite simple. We are going to the moon and explore by LUPEX. Then again, the purpose of LUPEX mission is resource exploration, not for science. But data to be obtained could be used for the sciences. And we try to incorporate in LUPEX mission so that we can have a most scientific results from this mission. We also considered is the landing expression really necessary? And the answer is yes. Ground observation has a difficulty in to observe polar area, and impact experiment was considered, but the special distribution will not be known for only one impact or a few impacts. Remote sensing from orbiter, this is a possibility. Neutron spectroscopy from low altitude maybe tells us the distribution of water reservoir in the polar area, but we realize that already mission named the Lunar H map has been proposed, so we don't have to make the similar mission. And landing exploration is probably the one most efficient one, and abundances can be measured by drilling samples. And also we understand that multi-landers are desired. Only one exploration cannot answer the whole questions. So that means that both Viper and the LUPEX should be conducted by US and Japan and India. Okay, this table shows the mission requirements for LUPEX. And this table includes the technical aspects, but also has requirements for instruments. And with these yellow cells are important for us. We wish to conduct a sample analysis, in situ sample analysis, to measure the DO/H ratio and abundances of volatiles using mass spectrometer. We also think that the new technology is important for the future lunar mission as well as Mars missions. Drilling technologies, sampling from subsurface, and in situ analysis. So should we insisting that those technologies should be involved in LUPEX. Okay, in the task force report, we picked up many science topics, and what we try to do is that we make a list of most important topics, and we distinguish the most important topic for the Japanese planetary scientists. This table is showing that some events and science topics categorized by the age and dominant event at that time. And for example, 4.5 billion years ago, a solar system was formed, and during this formation processes, H2O and organic compounds are transported from outer solar system to inner solar system. 3.8 to 3.5 years ago, late heavy bombardment occurred. And after that, the habitable environment has been slowly, not slowly, but the habitable environment changed on the planets. And at present and in the near future, we hope that the human beings go into space. So the first priority should be that science is possible only on the moon. And we picked up to, let's say, the three topics are the most important and categorized in this area. The first one is to try to find the evidence of late heavy bombardment. And the second topic is to study the thermal history of the dry system, I mean the moon. And the third topic is the water supply from solar wind, I mean generating H2O at the surface of the moon. The second important topics are the science achieved best on the moon, not on other planets. These include the physics and chemistry of giant impacts, magma oceans, and study of ancient crust. Impact processes, regolith formation are also important, should studied on the moon. Also, for the future activity of human beings, resource development and innovation of new technology is important. Other topics could be achieved by a small body sample return or Mercury mission, etc. So I'm not talking those parts anymore. This slide shows one of the most important science topics. The first one is supply of volatiles. We wish to know the spatial variation and also as well as a temporal variation of water supply. The process would be very different at present and 4.6 billion years ago. To understand this topic, there are many related science topics, such as late heavy bombardment and greater chronology and study of ancient crust and resources. Okay, this figure showing is prepared by my colleague and showing that the supply and loss processes of volatiles on the moon. After Kaguya mission, we realized that many parts of solar wind proton has been absorbed at the surface on the moon. So that means that the water would be, is likely generated by a reaction of solar wind proton and oxygen at the surface. And we wish to examine this hypothesis at the surface on the moon from direct observation by landers. This study is somehow related to the magnetic anomalies and difference of albedo of magnetic anomaly regions. The second, we also wish to understand the internal evolution of the moon. This is very much related. We think this is very much related to the stability and fluctuation of habitable environments. For Mars, it has been proposed that the climate change occurred 4 billion years ago by a massive volcanic activity. And similar phenomena has occurred on the Earth. Permian-Triassic biological crisis is said to be triggered by Siberian traps, large igneous province. So, and also the global, we know that the global resurfacing or lunar mare volcanism occurred on Venus and on the moon. So this volcanic activity has a huge impact to the habitable environment, and which is very important issue for us. And also, we think that the moon is an end member of dry body. Another end member is the Earth, which is very wet. So this dryness or wetness may control the volcanic activity of the planet, and which in turn changes the habitable environment. To study this internal evolution, we wish to put global network of seismometers on the moon. And this cannot be done by one country. I think we need international constellation of geophysicists. And for Japanese, that seismology and volcanology are very popular science. So we are very eager to attend such international collaboration. The third issue is we also discussed about the local study of local variation of lunar crust, but this is not supposed to be the highest priority. The highest priority in the view of the lunar science. I mean Artemis, and this topic includes resources exploration and also some kind of study of early evolution and internal structure of the moon, and requires technology development. Okay, such as the access to steep slope areas. Resources on the moon is another issue, and as I already said, the volatiles are important, and some says that some scientists are interested in other elements. So also that from the view of engineering, the mining of radioisotopes are also interesting. And it is also interesting in the view of the lunar science, pure lunar science, because this is somehow related to the discovery of arc leap. Impact processes, regolith formation is supposed to be the secondary importance. I mean, not the first priority, but could be studied in Artemis mission, and this is interesting for us because the gardening process or space weathering is very much related to the exploration of asteroid Ryugu by Hayabusa 2 mission. Okay, science of dust has been discussed many years, many decades, and we think this is still important and unresolved issues. Okay, the last topic is the exploration of shallow subsurface. 2 years ago, we think this is the second priority topic. However, we reconsidered the importance because the study of the regolith, properties of regolith, is very important for civil engineering on the moon. So I will discuss this point later again. Okay. We are also considering to the future of Artemis. We will move to Mars to study the hydrosphere on Mars. Again, we are interested in habitable environment on Mars, and the geologic map based on visible to near-infrared spectroscopy are shown here. However, it is very different from the geologic map based on the gamma ray data. The difference of these two datasets are the depths of the studied depths. And these differences indicates us that the geomorphology and the spectroscopy is different. I mean, water cycle is essentially under the ground, which is different from the geomorphology and the spectroscopy studied at the surface. So we need a new technology to understand the hydrosphere of Mars. Obvious methods candidates are radar sounder, gamma ray neutron spectrometer, and in situ drilling. So we hope to develop these technologies on the moon first and apply them to Mars. Okay, these are the technologies related to the lunar sciences. Specifically, we think that there is a technology commonly needed for solar system explorations: pinpoint landing, access to survey area, sampling, in situ analysis. So again, we hope to develop these technologies on the moon during in the Artemis program. Okay, and also we think we had better to prepare for human activity on the moon, and this is some kind of partly has been achieved here in the ISS missions. So I'm not an expert of this topic, but there are many scientists who are interested in and hope to continue this science activity at the Gateway. Okay, so this figure shows that the scientific interest and engineers' interest and we try to identify the most important intersections of science and technology. As I said, that the two important topics for lunar science is supply of water and internal structure thermal histories. On the other hand, engineers wish to develop a new technology related to M-class missions and multi-small landers or mini sample return missions from as many locations as possible. So considering these interests of science and technology, we think that the future mission by future Japanese mission should be either mobility related to mobility on the moon, surface exploration, and sample analysis. Okay. Now I wish to move to the most recent study by the task force teams. The second task force team was organized aiming to revise the previous report in 2019. However, it became apparent that the overall scenario is most important. First, in the second task force team, we considered first for the links between the science and technologies. And we are proposing, there are three major issues. The first one is that seismic exploration will be very important for science and also soil mechanics technology. These are very closely related and could be used for to understand the lunar science and also for the civil engineering. Investigation of lunar environments has been considered important. And the third is a new one. Third issue is new one. We think that the big data science would be a very major part of Japanese Artemis mission. Use of science data for industrial for the industry to use the science data, we have to provide the science data for them to use for the industrial people can use easily. Also, the amount of the data will increase quite rapidly after Artemis mission. So we have to consider the new technology to treat big data. The second, we also consider that the link between the science technology and industries. And we are proposing that the infrastructures will be developed by private sectors, not JAXA. There are some examples. The one is that from soil mechanics to civil engineering. This is in Japan, that civil engineering is a major industry. So it should be also worked for on the moon. Energy supply and telecommunication system can be operated or owned by private companies. And transportation to the moon and on the moon can be conducted by private companies such as Toyota. And actually, Toyota has been already working with JAXA to develop a pressurized rover. So, as I already said that we need an overall scenario to define the science in Japanese Artemis. So we set a tentative goal for next 20 years. It is to construct lunar base for 20 to 50 astronauts can stay steadily on the lunar surface. And we set this goal to in 20 years. Then such activity will be expanded by the industry and private sectors. And then the JAXA will go to Mars. With this goal, we identify issues to be solved in next 20 years. That includes medical science, sociology at the lunar base, agriculture on the moon, and civil engineering, constructing structures on the moon. And in order for that, we need to understand the environment, and we need a new technology for transport and exploration at the surface. Then we further break down topics into in details. Very first, at the beginning, we hope to study the water abundance by LUPEX mission. Also, we should consider about resources for construction and energy. Also, we should work for the seismic study of shallow subsurface, as well as soil mechanics. Then this activity can be categorized into three types. First 5 to 7 years, we focus on the investigation of the lunar environment. Then we move to the construction phase. And finally, we will consider how human beings stay on the moon. So in these phases, we can conduct science of the moon, science from the moon, or science on the moon. At the same time, we considered how we develop human resources in Artemis mission, and also consider the data policy. In the very beginning, the graduate students in Space Science Department start working to investigate the lunar environment. Those people will move to the construction or private sectors. Then finally, those human resources can be utilized in private developers. Meanwhile, in the very early phase, we should keep the open data policy for the scientific data sets. But soon, those data should be used by the industries. So there will be new application and technology should be developed for big data science. And finally, data will be probably owned by the private companies. These are the views currently at present for us that And we are proposing this view to the ISAS and JAXA. And at the end, I would like to emphasize that we need collaboration of scientists. Governments and space agencies have been started constellation or collaboration in Artemis mission. Probably the scientists has their own bridges between countries. It is somewhat kind of expansion of league activity. And I hope that lunar sciences continue in this century also by a network of international scientists. Okay, that's all. Thank you for listening.
Questions, please unmute yourself and then tell us your name and then ask the questions to Professor Namiki. One question I have, Namiki, is that you talk about this I think the last one or two slides you mentioned about this mini sample return mission from the moon. What is that? It's
hard to say, but engineering scientists are more interested in small satellite missions rather than middle class missions. So they hope to send as many small landers on the moon as possible, and make a sample returns from these small landers. So they try to increase the landing site.
Okay.
Yeah.
And how big would those spacecraft be? I mean, would they be of the CubeSat size or bigger?
Well, they are, this is my guess, but they are hoping to, let's say, not as small as CubeSat, but supposed to be, say, 1 meter size small satellites, something like that.
And then they have to return, right?
They have to return it. Probably they are considering to use the through gateway. So bring sample to the gateway first.
Okay, of course, yes. So the LUPEX mission is your first step in the Artemis project. Do you have any I would say contribution to the lunar gateway? I was saying that are you also having any plan for the lunar gateway space station?
Well, actually, not much. The scientists working for ISS are interested in activity in gateway, but geophysicists and geologists are not very much.
Because you cannot go there.
Maybe, yeah.
Yeah. Yes. So if there are no more questions for now, I mean, of course, when the audience, if then they have questions later, I think always, I think they are welcome to contact you, right, Namiki-san?
Sure. Yes. Yeah.
And then if you don't have the Namiki-san's address, you could send a question to me. I will relate it to Namiki-san. And also that those slides figures you have from this report, right? They published. Are they available?
Well, they have been published in Japanese, so I can send these slides later, but I have to make sure that they could be open to.
Yeah. Sure. Okay, Namiki-san, thank you so much. Please say a basic report on your study report. So I hope that the next time you'll come back and I will ask you to talk about the science you're doing.
Okay, thank you very much.
Yeah, Namiki-san, thank you so much. Have a good day.